Well, hello there again. This is the second talk on the Australian lamb industry. And specifically here, we're going to focus on carcass measurement technologies and how they've evolved over the years. Now, our system of carcass description in Australia was based on, and it largely still is based on, the GR measurement. This is a measurement developed in New Zealand, and it's the total tissue thickness at the 12th rib, 110 millimeters from the backbone. And this paved the way for carcass description. So now we have a system where we've got 5 fat scores in Australia, and they go from 1 to 5, from lean to fat, and they've got a GR measurement that underpins them. Now, the problem, of course, was, okay, we can measure it with a GR knife, but how do we have measurement at chain speed? And in the 80s, a probe was developed called the Osment sheep probe, and it was able to measure the GR measurement with the human operator, as shown in this diagram, at up to sort of 9 to 10 carcasses per minute, and with 90% of those carcasses within plus or minus 2 millimeters. And that was the accepted standard at the time. And the paper that describes that first work is given in the bottom. But of course, wanting to move away from the human error issue and head towards automation, it saw the emergence in the early 90s of what's called the ViaScan technology. This was Australian developed technology, and the idea was to allow online measurement of meat yield and other traits, and to improve the prediction of yield. Now, this shows the system. So on the left, we've got a camera in a box with a light source. Then on the right, we have the updated system where the camera's hiding in behind this metal enclosure here. And as the carcass goes along the chain and backs up to this, the image is captured of the carcass. And that image is then interrogated for a whole lot of different measurements, and the algorithms built into the system provides the predictions. Now, we did some work published here in 2004, which looked at how much better ViaScan might be at predicting yield than, say, using just the GR measurement. And you can see when you get to the bottom of the table that with hot carcass weight and ViaScan measures, we can get an accuracy over 50%. That's what the R squared is. And also the precision, if you like, of the prediction, the RSD, was around about 2%. So this looked like very favorable technology. Online, didn't need a human to operate it, and could sit there and take images and give the predictions. Now, coinciding with that, the maintenance of this Osment sheep probe became problematic because the company that ended up taking the rights to ViaScan also had the rights to the Osment sheep probe. And of course, they wanted to focus on selling the more expensive ViaScan. And so their due diligence with the Osment sheep probe fell off. This created a problem for industry because they couldn't get the thing fixed. On top of that, from the original work, which is funded by Meat and Livestock Australia, they set up a company to commercialise this technology, the ViaScan. But they went out in an aggressive manner into the Australian processing industry with a marketing plan that was flawed. And basically, it wasn't attractive to processors at the time, and they just turned them away. And so it was only taken up by 2 abattoirs in Australia. One of those abattoirs closed down. The other one still exists. I'm not sure whether they actually use the technology still today. But it was adopted by a major meat processor of sheep meat in New Zealand, and they developed their own algorithms built into the system to give them predictions. So in a way, we had not progressed too far in Australia, and we were back with a problem, how to measure GR. So we looked at using the Hennessy grading probe on a fairly large study, more than 500 lambs. And in this study, using the Hennessy grading probe, which was developed originally for use in pigs and also in beef, and I did some early work in the early 80s on beef, and it works very well in beef. But of course, we couldn't measure GR because it's got the type of probe that it is. It's got to penetrate something. It can't hit a bone. So we had to go as close to the GR side as we could, but between the ribs. And we just found that essentially when we looked at the data using this probe, that it just underestimated. And you can see it from this graph. So you've got a measurement of the actual fat depth here over the eye muscle on the x-axis, and you've got the Hennessy grading probe measurement at the top, and you can see it's under predicting. And so this just simply wasn't good enough to be introduced to industry. We did look at a few other options. One of those was the idea of the direct tracking of cuts through a boning room. And we did some work there with a number of carcasses using the same range of cuts that we'd used in the Viscan work, and seeing whether if we just had the weight of a cut, could we use that to actually give us a prediction of meat yield. And here we can see this was the best equation, the best model, that with forequarter weight, measuring GR and having a fat score measurement, we could actually come up with a prediction. And this shows you some of the actual data spread, the meat yield versus the actual prediction. And it's not perfect by any means, but it's certainly better than using just a GR knife. And then if you looked at different models and the simplicity of those models and just using cuts, if you weighed the forequarter and the short line, that was actually the fourth best model. So that's great. And you can see where hot GR sits down at the bottom. It was ranked 126 out of the models. So not very good at all. And the actual error there was quite large. The problem is, of course, you've got to be able to have the ability to track the cuts and identify them back to the carcasses. So in the sheep CRC program that I mentioned in talk 1, there was a lot of work undertaken also on carcass measurement. And the first probe that we looked at there was a probe developed out of Scandinavia called the Karamatech probe. It was based on impedance, but because of the design, also had the ability to measure GR. It was built originally to measure IMF. It didn't work for that, but we tried it for measuring GR. And you can see one of my former team members here, Dr. Stephanie Fowler, using that Karamatech probe to measure GR. And again, this is what the data looks like. So we've got the probe GR depth along the x-axis, and the knife GR measured with the knife, hand knife, on the y-axis. And you can see two things, that A, there is an underestimation again with the probe, but also a huge spread around the line. So lots of error. And again, we deemed that that probe just wasn't going to be suitable for use in the Australian lamb industry. More recently, we've tested a probe called the ICE probe, built in Iceland, funny enough. It's a very well built, simple device, and in our eyes showed a lot of promise. And this is Stephanie using that probe again. And here are some of the data. And we can see that looks like basically it's doing a pretty good job in terms of estimating right across the range, so as you get fatter. But you do notice that the spread around the line gets greater as the carcasses get fatter. And if you look at the next data, you can see this is sort of like the residuals or the error. And the error is greater in the fatter carcasses. And so we deemed that this probe had a lot of promise. With some modifications, potentially it could be a very good option for the Australian industry. Unfortunately, the funding bodies sort of capitulated on it, and it hasn't gone further than that, but it is a potentially good technology. Now, one of my other former staff members also did some work sort of around 2014, 15, to actually look at industry and what did they think were valuable traits to measure. And we can see the ones they currently measure here: carcass weight, of course, animal age in Australia, that's measured by dentition, looking at the teeth, fat score, and 40% or so measure GR. And then it goes down, and there's a few that measure some of these other traits, but not that many. And that's reflected here. Similar sort of thing. You can see carcass weights is recorded. The GR is recorded in more than 40%, but not all cases. pH is measured in by 30% of processes, and that's linked to the Meat Standards Australia scheme. And then, of course, lean meat yield, not measured at all at this time, because they just didn't have the technology to do it. Now, interestingly, when you say to them, well, what do you see as the most important traits to measure? They came up with tenderness as the most important trait, then the pH, the animal age, meat color, GR, and then into the yield traits. And the sort of, if you like, the more eating quality traits like IMF were much further down the preference list. So particularly interesting as you try to work out what are the needs of industry. Here, the question was, what's their willingness to use an online tool? So if we developed an online tool for GR, would they use it? And more than 70% said they would. Interestingly, if we could predict tenderness too, they would do that, which is an interesting concept, being able to actually measure the tenderness as opposed to developing systems to improve the tenderness so that, in fact, it's not actually tough. pH, animal age. Again, the yield ones started to show up here, that they would actually use an online tool to predict lean meat yield if you had a tool to do that. So, in essence, in Australia, really the adoption of what we call yield-based trading, apart from using hot carcass weight and GR, has been low. But there has been renewed interest in this in the last few years, particularly with the development of automation. And the sheep CRC started work on DEXA, dual energy X-ray absorptiometry. It was underpinned with computer tomography, CT scanning, to give it the basis for its accuracy. Hyperscopic imaging and NIR have been investigated to predict a range of traits, but particularly intramuscular fat, because it's a proxy for eating quality. And that work was actually extended to a new program that was called the Advanced Measurement Technologies, or ARMTech program. And that program has been quite sophisticated, looked at lots of different pieces of technology to see whether they could actually be good for purpose. And some of them, of course, have been abandoned and others have been developed. And now there are a number of abattoirs that are actually using the DEXA, and they're using it for the measurement of lean meat yield. And it's, as I said, it's underpinned by CT scanning as the gold standard. But it's largely linked to the use of DEXA technology for guiding robots during carcass boning process. So we have a number of abattoirs in Australia that use an automated process as a part of the boning of lamb carcasses now. But if you go to that YouTube that's shown here, you'll be able to actually see a company and a system installed in the company operating. In one case, there's one abattoir that's actually using the DEXA for measuring carcasses hot on the slaughter chain. So not even for boning purposes particularly, but actually just as a measurement of lean meat yield. And this enables the sorting of carcasses prior to boning. It also enables quicker feedback to producers because you get the data in real time. Now, this shows you the carcass measurement system based on the DEXA approach for the automated boning. And what you can see is up here, this is a shielded room because these are X-rays, and the carcass is subjected to the X-ray. Here's the sensor detection board here. And as the carcass goes through, the image is collected, it comes out again. This is the sort of image that you might get. This image information is then fed into the computer, which directs then the cutting system to determine where you want to cut at a particular time. Now, the problem with that system is that the DEXA system as it is is not very discriminating in terms of the image quality. So a lot of work has had to go into actually increasing the sensors in it to improve the image quality so that it could be used as a prediction for limit yield. Of course, DEXA is costly. We're talking in the millions of dollars, and it simply won't suit all abattoirs. In the past, as a proxy for limit yield, of course, we've used GR dish depth, and it's still been used and measured in some plants, particularly just by using a simple knife. The latest approach is at a prototype stage, and that's actually to investigate the use of microwave and whether microwave can be used to give us a measurement of GR. Again, it still relies on the human, and the technology is still at that prototype stage. So in some ways, we have not progressed all that far in terms of measuring GR. Certainly, we have some abattoirs that are using the sophisticated DEXA equipment to give direct measurements of lean meat yield. But from a marketing point of view also, you need to be able to actually give a GR measurement because it tells you the degree of trimming that's required. In terms of meat quality traits, a lot of the focus has been on intramuscular fat. As I said, it's a proxy for eating quality. We've done a number of studies to look at different sites of measurement. The first paper listed there looks at measuring hot in the chiller, the topside muscle, because it's easy to get access to and give that a prediction of the IMF level in the loin. And it's moderately successful and shows some promise. The other alternative is to measure directly onto the loin, and you can see Stephanie here measuring with a INIA device directly into the loin, but you have to make an incision for that to occur. Now, the data is actually quite encouraging. You've got an R squared here, so an accuracy of about 60%, which is quite reasonable when you think about biological systems and measurement systems. There's obviously differences in the kills here, but essentially it shows some real promise. So there's been testing going on with a number of different probes. The first probe is the MEQ probe. This is like a private company that's developed this probe. The next shot shows some of our work with an honours student there measuring on the top side. And then they've got the SOMA, which has been developed in Japan, but it hasn't been adopted in Australia. And then the last one is really using like hyperspectral cameras, but they're only any good in the lamb industry in the boning room. And that means that you've got to make the decision then about what you do with the product one day later than if you can measure hot. And what's actually happened is that a commercial company, a commercial abattoir, has actually adopted the MEQ probe. And it's been used to measure IMF at chain speed on hot carcasses in one abattoir. So combined with the lean meat yield in the same abattoir using DEXA, that means that they can actually get this data in real time and measure the lean meat yield and so forth. Here, we see that there's an ability now with this system to actually pay producers an individual price. And here you can see the highest price is going to be paid for a carcass that's got a lean meat yield of something like 57% and weighs 24 kilos. And with the DEXA, of course, they can identify those carcasses. On top of that, this company is now offering a bonus that if the predicted IMF in the loin using the MEQ probe is 5% or greater, then they will actually give a bonus to the producer. Now, it's worth mentioning also that payment systems for lean meat yield have been developed in the past. In the 80s, a computer program was developed called Lampro, and I was involved in that with the computer programmer. And that was the idea of actually coming up with a costing system based on yield. It was before its time. The playing field has now changed, and the old adage is sometimes timing is crucial. So other ways of measuring, particularly traits like intramuscular fat, is to look at other things apart from INIA. And Raman spectroscopy has an advantage in this space. And the advantage with Raman is, of course, that it's not dictated by the water content of the muscle. And we've done extensive work in this space and continue to do work. And here's the way that the technology is developed. This is a handheld Raman spectroscopy device, at the time worth about 65,000 Australian dollars. But you can see it's very light and portable. And here we're measuring topside muscles in a large project to look at eating quality and so forth. And we still have that data to be processed and published yet. But we have done some work in another study. This was a nutrition feeding experiment. We had 48 lambs. They were scanned with the Raman device. 60 untrained consumers. They assessed the eating quality after 5 days. And we showed that actually there was quite a reasonable prediction of eating quality using this system. And so there's quite a bit of promise there, and that's still to be developed. So as I'd see it, more work is required to see these systems that can measure traits with accuracy under processing conditions. And we need that to arrest the decline in LMF, because we need direct measures. There is potential to measure other traits. And if you want to see a whole host of papers on this in this space, please go to that website, in Meet Science. We published a special issue with a whole stack of papers on this development in carcass measurement. And again, gracias, and thank you for your attention.